Um, so Parvati and Jin, would you like to briefly introduce yourself first, since you are newcomers?
Sure. Um, I'm Zijing. You can call me Leo, and I study at Columbia University in statistics. Last semester, I had a course called Statistical Machine Learning. I audited it, so that's why I'm very interested in this project. And it's very good to be here to have a chance to collaborate with everyone here.
Okay, thank you. Seems that Parvati has some problem
Uh,
with. Oh, oh, oh,
yeah,
sorry,
I
sorry.
was just able to join. I think it was problem with Google. I was able to join for two meetings simultaneously, and one meeting was about machine learning. So I think now it's fixed. Hello?
Yes, we can hear you.
Okay. Yeah. So now I think now everything is working fine. I don't know like what happened. And currently, I'm a student at San Jose State University, and also I'm working as a research assistant at University of Washington, where my specialization is in big data technologies. And nice to meet you all.
Okay, nice to meet you. Thank you. And since we don't have much people in our group, maybe we can uh, give a quick round of introductions of ourselves as well. So I can start with myself. Uh, I am I am now a rising senior at University of Michigan, majoring in computer science and minoring in math. And I am also the leader of our deep learning research group and hope we can collaborate together to learn more things in the field. So nice to meet you all. And Iman, would you like to introduce yourself?
Sure. So I'm a PhD candidate at the University of Michigan School of Information. I got my undergrad degrees in computer science and information management. I also got two specializations in Master of Information Sciences from University of Michigan in human-computer interaction and information management for economics, and now I'm doing my PhD with Professor Paul Resnick as my advisor at the School of Information, and I've been working with Yue, Jing, and Jiayun um, since the beginning of the summer. And Meta was my student last semester in my data science class. So um, the new people to me are there are three new people, new faces, and voices. So hopefully we will have a good collaboration throughout the semester, and we will be able to publish a couple of good papers.
Okay, so Jiayun, can you hear me?
Yeah. Let me briefly introduce myself. My name is Jiayun Zhen. I'm also a rising senior this year, and I'm also majoring in computer science. Um, I worked with Jin Tao and Eamon from with a natural language processing project with One Academy website. But we're learning deep learning right now because we our research involve a large part of deep learning. Um, yeah, that's all for me.
Okay, thank you. Jing.
Hi, my name is Jing, and I'm a second year master student in School of Information at University of Michigan. And yeah, I'm working with Jiayun and Iman about the NLP and both deep learning project right now. That's it.
Great. Okay, Meta.
Hi, my name's Maida. I'm a rising senior at the University of Michigan. I'm majoring in CS, data science, and minoring in math. And yeah, I was in the class with Iman last semester, where we did a lot of causal inference stuff, which was super fun. I've done the ML and AI courses at Michigan as well. So this is like a field that I'm really interested in, which is why I think this project is super. And I thought it'd be great to work on.
Nikis?
Hi, my name is Nikit. I'm a rising junior at U of M, and I'm studying CS, and I'm just interested in deep learning, which is why I'm here.
Okay, so everyone has introduced yourselves, so we will start with today's presentations. I haven't received comments in the post I create in our private channel. I want to confirm whether anyone would like to make a presentation today.
I'm sorry, I haven't seen the message. Is that what you referred to?
The title is August 25 meeting. I created it yesterday.
Oh, it's on the Teams?
Yeah, Microsoft Teams.
Okay.
So, would you like to share with us something you learned this week?
All right. Me?
Yeah.
Can you give me like a minute to like gather my thoughts? I'm sorry, I didn't know this was something that was happening.
Okay.
Sorry, just give me like a minute.
And for that post, I just want whoever would like to present the notes they proposed on the online academy to leave a comment of the topic they like to share, so everyone can have a brief idea of what will be covered in this week's meeting.
I had a question.
Yes.
While starting with the node in the Codility platform, so like how should we start it? Like, should we attach to your node of machine learning, or how should we proceed with the deep learning? I've seen that you have created one node. So how should we start with the extension of nodes?
Have you finished the tutorial I have sent you? Or
No, not yet. I have just started with the book with the deep learning specialization. I just got to know from you today that I can take the courses online in Coursera for free. So, say in case while studying, I want to create the notes in the platform. So, how should I proceed with it? Should I start creating with my own separate notes and then join it to the main node? So, how does that work? I'm really not
yes.
sure.
I have sent you the tutorial for how to work in our platform, so I think you can first go through all these tutorials, and then you will know how you can collaborate to our group. I have sent, yeah.
And should it be of the since you send the Coursera material, should it be constrained to only Coursera materials, or like can the implementation be taken from say other facilities like Data Camp and so other things? You know, we can practice our implementation there, and whatever we have learned from there, can we attach the notes on that? So how does that work out, or it should be only be restricted to Coursera specialization?
At the moment, we focus on the content and the textbook. But if you think that something you have learned else from the other place are really helpful and you want to share with us, you can also create the corresponding notes and cite with the resources and share with us in the meeting.
Okay, cool. Thanks.
So just to add to what you explained, you can create, if you find a helpful reference, whether it is a blog post, a research paper, another book, whatever it is, as long as it is accessible to everybody in the meeting, like in the team, you can just create reference nodes for each of those references on One Academy in the appropriate places in the clusters, like in hierarchical structure, and then you can use those as citations and summarize what you have learned from them and shared with the rest of the team. So there is no restriction on what you can explore, but we are all trying to deepen our understanding of foundations of deep learning for now, and we started with this course and by specialization and textbook by Professor Ng, and we're going to go beyond this as soon as we are done with this specialization. We'll continue with more recent research papers, textbooks, and whatever we can find helpful for our team.
So say if you're like stuck in some part of statistics, so like I have worked intensively in big data, but I have lost my touch in statistics. So but I have taken a couple of courses during my undergrad in statistics. So I just want to brush up my skills on that so that I can be more productive in taking the deep learning specialization. So say if I learn something about statistics, something new from the book. So can I present it here before I start with if I encounter something in the deep learning course module of Professor Andrew, and can I combine both and present? So how does that work?
Sure. So I don't know to what extent, so you can better answer this question. I don't know to what extent statistical analysis can help with the deep learning specialization. In general, statistical analysis will help with the research we are conducting. And we have a lot of notes about statistical learning, causal inference, and those things on the map, on One Academy map right now. You can extend them, you can just improve them, add new content to them. But whether we want to have a statistical analysis presentations, or we just want to focus on deep learning presentations, depends on the schedule that UA has for us.
Okay, thanks.
So UA, do you feel comfortable if we also present the statistical analysis, or it should be all around deep learning?
I think I'm not sure to what extent statistical analysis is related to deep learning, but if the content is closely related to some of the concepts in deep learning, then I think that will be welcomed. Yeah.
Yeah, if it is like about causal inference, so UA has added a lot of nodes to the map about causal inference. Meta also has a lot of them. So Meta was in my data science class last semester, and we studied causal inference as a group, and so you can find a lot of nodes there. If you're interested in like connections between deep learning and statistical analysis or causal inference, that would be a good idea. But otherwise, I don't know to what extent it can help the whole team.
Okay, thanks.
Sure.
I have I don't know, it's kind of a strange question, and I feel like I should have probably asked this a bit sooner. But
Can you speak louder, please?
Oh yeah, of course. Sorry.
Thank
Can
you.
you hear me better now?
It's a little bit better.
Yeah. Okay, I'm not sure what the problem is, but I have a quick question about what we're trying to accomplish as a group. I know that right now we're trying to get through the deep learning course on Coursera and the textbook, and just sort of build the map from there. But is there like a specific goal in mind, or are we just trying to explore the topic more and see where that takes us?
We are 3 groups of people here.
Yes.
We have Elijah and Victoria who are not attending today. Victoria had another like master's orientation program, and Elijah had another responsibility. So they are not attending this meeting today, but they are my IAs in the instructional assistants in my deep learning course this semester. So they are doing their own thing, but they're also learning this specialization together with us. We have Jing and Jiaoyun, who are from the NLP team, and they have their own research questions. They're working on their own like literature review and other stuff. They're also attending these weekly meetings for going through the deep learning specialization together with us. And we have everybody else who is a member of deep learning team. And the deep learning team is going to explore, so it is going to start with 2 research questions that we have been discussing with Yue for a while. And so we start with these 2 research questions. After we're done with the deep learning specialization, we'll do literature review, recent literature review on these topics. If anyone in the team comes up with other research questions that the whole team is interested in working on, we'll all can decide, we can vote and decide to continue working on those research questions as well. But for now, there are 2 research questions that we have already discussed, and we are learning the deep learning specialization together to learn the foundations of the field. And we're going to continue with other references, like more recent studies on these topics after this specialization together. But after finishing this specialization, the other teams will diverge. They will continue their own research. Only the deep learning team will continue these weekly meetings and will focus on these 2 questions for now.
Right. I'm just sorry, I was just confused because you mentioned that statistical methods wouldn't necessarily be the focus of this group, and that we should only like focus on causal inference and deep learning as like a set together if we were interested in that, because otherwise so I didn't know if we were like not focusing on that or if that was just like a part of what we were focusing on. So I just had to ask the question.
By the way, causal inference is highly interconnected with the statistical analysis. What I was saying is the statistical analysis would not help that much with foundations of deep learning as we learn through this specialization. Like in this specialization, we discuss a lot of linear algebra concepts, but not statistics that much. And so after we are done with this specialization, one of our research questions is the intersection of causal inference and deep learning, which requires knowledge of statistical analysis. But for now, I don't see any reason to present the statistical analysis for the whole team, because the reason these 3 groups joined the same weekly meetings was because people in these 3 groups wanted to just develop their foundations of deep learning through this specialization.
Okay, that makes sense. Thank you.
Sure. Is there any other questions?
Okay, so thanks, Iman, for clarification. And if no one would like to give a presentation today, maybe I can give a short presentation about the CNN architecture, since we haven't covered it last week.
Actually, I can present.
I can
present about the gradient descent, because we talked about it last time, but we didn't go like deeper in that concept, right?
I feel like these are very good topics. Is there anyone else who wants to present today?
Yeah,
Okay,
I read like 30 pages of the book, so I can share something, but it's not structured.
So we
If that's okay,
usually
I can
present what we have already added to One Academy. So you'll see how it works. And Yua has recorded the previous meeting, so you can just go through the YouTube video for the previous meeting and learn what she has already presented.
Oh, got it.
Great.
So so overall speaking, what's the progress of you? Like how many pages of the book have you already covered?
I think none.
I think Yua can answer that question better than me.
Yes, for the already existing nodes on the deep learning map, most of them are from another book that I read previously. And since we have just construct our group to work on the book we are working at now, so our goal is to improve the map we already have and also add more nodes to have deeper learning in the field. So you can first go through the existing nodes to see which part needs further further researches and to make certain improvements or create new nodes as you like. Yeah.
Got it. Okay.
So Jing, would you like to start with a presentation?
Sure. Okay, so last time you introduced us what gradient descent, and we know we can apply that to the error function to minimize the cost of the error. So, so to implementing that, assuming that the error function is JW with only one parameter W. To minimize the error, we can update the weights W as follow. Like W equals W minus alpha times the derivative of JW, where alpha is a learning rate and this part is the derivative of JW with respect to W. And if the error function has two or more parameters, for example, a weight W and a bias B, we can update them one by one as following. And you guys can notice that it's a little different between this function and this function because this symbol is a stylish cursive D, denoting the partial derivatives because there are two variables here. And yeah, and before, so we need to calculate the derivatives. So what is derivatives? So the derivatives of function y equals fx of a variable x is a measure of the rate at which the value y of the function changes with respect to the infinitesimal change of the variable x. It is called the derivative of f with respect to x. The derivative of a function of a single variable at a chosen input value is the slope of the tangent line to the graph of the function at that point. So like this picture, if you want to calculate the derivative of y at point x1, you can nudge x a little bit to x2. So the delta x is the infinitesimal change of x, and the delta y is the value change of the y. So delta y over delta x is the derivatives. And here is some examples of derivatives for different functions, like a linear function 5x, the derivative is just 5, and like fx equals to x squared, and derivative of f is 2x, and the x cubed is like 3 times x squared, and the log x is 1 over x. And this is all the foundation to compute the derivatives of cost function to our models. And so we can see
just a quick point. So the basics of like derivatives, those things should be like like definition of derivative and these things. These should be prerequisites to other stuff here, because like if you don't know what derivatives are, there's no way to understand gradient descent and those things, right?
Yes. So this one
if you just change the parent-child links, that would be great. Thank you.
Okay, no problem. So, so let's see an example. We can consider the logistic regression as the simplest neural network with only one layer. So the intermediate value z can be computed as follows. Z equals W, the weight transpose, and times X plus the bias B. And the final output A is the result of a sigmoid activation. And the loss function for one example look like this. This is also called the cross entropy function. And if we have, if we only have 2 features, x1 and x2, in order to minimize the loss function, we can apply gradient descent to update W1, W2, and B. To compute the derivative of the loss function LAY with respect to W1, W2, and B, we need to compute the derivative of L with respect to A and Z first. So here's the formula for that. So we can compute the derivative of L with respect of A first, and then the dz is equal to the dA times the dA over dz. And then we can compute the dw1, dw2, and db by using the dz results obtained here and times dz over dw1, which is x1, and the same to w2 is the dz times x2, and db is dz times 1 actually. And if you want to go deeper with how to get the derivative of the loss, you can go through the Kurosawa the first week, not first week, the first course in week 2. Yeah. Here's like a workflow of this. So the how to say that? Oh, the forward propagation is from x1, w1, x2, w2, and b to compute z and a, and eventually the loss function. And then we can conduct the back propagation to compute the derivative of loss function with respect to A, Z, and W1, W2, and B in order to update the weights and the bias, the parameters. Okay, and this is only a simple for one single example, but in reality, we often have like a set of data, multiple examples. So in order to compute logistic regression, this gradient descent on m examples, we can use for loop to accumulate errors and derivatives and then average them. But it will take a long time to run on a big data set. So vectorization is a good way to get rid of the explicit for loop in your code. First, you can stack the m example horizontally into vectors of x and y, the capital X and capital Y. So the shape of capital X is nx m, where nx is the number of features and m is the number of examples. And the shape of y is 1m. Then you can compute capital Z and capital A by Low's formula. And the shape of Z and A should be 1m. And the derivative L with respect to Z, W, and B are as following. Yeah, I think that's pretty much it. That's what I
have a question here. So this is great. So in the previous node, do you have any child node or anything at the end of the day to show, and now that you have defined backward propagation, how can we use optimization on it? Like, how does back propagation work in terms of optimization of the weights for the neurons, for the synapses, to find the optimal values for the weights?
Okay, actually, because I have the formula here, so I didn't like put it again in this node. Because, okay, actually.
So my question is, how do you derive the formula in the parent node from the backward propagation that you have explained here? So I feel like you need another node for that explanation.
Okay. You mean a child node or parent?
So it should be the child node of its parent node.
Okay.
Like where you're defining the gradient descent. So this child node should be the proof.
Okay. So a child node of this to compute the real update.
No, the child node of its parent, gradient descent.
Oh, okay, here.
Yeah. So we need a child node for its proof. So by reading this node, we'll learn the formula. Okay, now I know the formula, but where is it coming from? So now if I know the formula, I can go beyond that. I can go through the proof to understand how it works.
Okay. Like a visualization of that, or?
No, just mathematical proof.
Okay.
That would be very helpful. Thank you.
No problem. Yeah, that's all I have for this week.
And also visualization would help a lot. So I think in the very first course of the specialization, Professor Ink has really good visualizations. I remember he had like actually a couple of videos, maybe 1 or 2 videos just about examples of how gradient descent works and like visualizing how it works with a lot of examples. If you can add notes about those examples and visualizations, that would be very helpful. But meanwhile, he doesn't go through the proof because the proof is kind of difficult for those who don't have a good background in linear algebra. I feel like it should be fine for you guys. And whoever is interested, they can just add the proof. And even if it is difficult for a couple of people in the team, we can just go through the proof and explain it collaboratively.
Okay.
Thank you. That was good.
Thank you.
Yeah, thanks, Jing, for the presentation of the gradient descent. So is there anyone else who would like to give a presentation today? Then maybe I can share with you my notes about the CNN architectures, and I will start the screen sharing. So can you see my screen?
Yes, we can.
Okay, so I will quickly start from the introduction of CNN and then start with the architecture. So as we have introduced, convolutional networks, also known as convolutional neural networks, CNN, are a specialized kind of neural network for processing data that has a non-grid-like topology. Examples include time series data, which can be thought of as a one-dimension grid taking samples at regular time intervals, and image data, which can be thought of as a two-dimension grid of pixels. The network employs a mathematical operation called convolution. Convolution is a specialized kind of linear operation, and convolutional networks are simply neural networks that use convolution in place of general matrix multiplication in at least one of their layers. So here is the CNN architecture. CNNs are made up of three layer types: convolutional, pooling, and fully connected. And here is a graph of CNN.
Would you please click the image or zoom in because it's not visible?
Okay. Is it more clear?
Yeah, I feel like the resolution of the image is low, or
Yeah.
it's getting better. I think it's being loaded here on our end. I mean, I had difficulty reading the text. Now it's a little bit better.
Okay. So in the convolutional layers, an input is analyzed by a set of filters that output a feature map. This output is then sent to a pooling layer, which reduces the size of the feature map. This helps reduce the processing time by condensing the map to its most essential information. And the convolutional and pooling process are repeated several times, with the number of repeats depending on the network. As you can see here, it is convolution pooling in the example showed in our picture, and then the condensed feature map outputs are sent to a series of fully connected layers, and these fully connected layers then flatten the maps together and compare the probabilities of each feature occurring in conjunction with the others until the best classification is determined. So then I will explain in detail what will happen in each kind of the layers. So first is the convolutional layer. In the convolutional layer, a filter, sometimes called a kernel, is passed over the image. Viewing a few pixels at a time, for example 3x3 or 5x5, and the convolution operation is a dot product of the original pixel values with weight or weights defined in the filter. The results are summed up into one number that represents all the pixels the filter observed. The first convolutional layer is responsible for capturing the low-level features such as edges, color, gradient orientation, etc. And with added layers, the architecture adapts to the high-level features as well, giving us a network which has the wholesome understanding of images in the dataset, similar to how we would. So as you can see in the picture here, this is the original image, and the yellow one is the filter. And it can be applied to each of the 3x3 grid in the image, and it will output the convolved feature here. So is there any questions?
Do you have a node explaining the benefits of doing such a thing, like adding convolutions to the data before putting it in the training phase?
I don't have that node.
So I remember, I'm not sure if I found that in the Coursera specialization or another textbook. I remember a lot of good examples for, has anyone studied the convolutional neural networks part of the specialization on Coursera?
I think, oh yeah.
Hi. Yeah, sorry. I had a question about the convolutional layer as well. In the output image.
Okay. What?
Sorry. Yeah. So the 4342432. I was just thinking. Wouldn't padding be something that we wanted to talk about here?
You mean padding?
Yeah.
Yes, I think. Yeah.
Sorry. Go ahead.
I think it is something that's worth to talk about, and but there is no node have been added for the padding part. So I think it is a very good direction for the presentations in the future.
Sure. Okay.
Yes.
Yeah, and I think if you can add more nodes about use cases, like when should I use a convolutional deep net? So we had another node about like fundamentals of use cases, but here after explaining the convolutional layers, I feel like it would be much better to add examples here of like what happens when we use a convolutional layer on like the picture of a cat. Like there are a lot of examples about these things out there, and I feel like just looking at those like convoluted images helps a lot with understanding why we do this. So if anyone comes up across like any of these examples, it will be great if you just add them as notes here.
Sure. I actually came across one of those when I was reading for today's meeting, so I can add that note for sure.
Great. Let's continue.
Okay, great. So now I will just give a basic introduction of the structure of the CNN. So we'll move to the pooling layer. So pooling is the process for of further downsampling and reducing the size of the matrix. A filter is passed over the results of the previous layer and outputs one number out of each group of values. This is to decrease the computational power required to process the data through dimensionality reduction. Furthermore, it is useful for extracting dominant features which are rotational and positional invariant, thus maintaining the process of effectively training of the model. And there are two types of pooling, max pooling and average pooling. So I think this can better explain how it works. So for average pooling, it returns the average of all the value from the portion of the image covered by the kernel. So as you can see here, for each portion, the average of all the numbers are taken and then output in the corresponding position. And for max pooling, it just returns the maximum value from the portion of the image covered by the kernel. Okay, so that's for the pooling layer. And finally is the fully connected layer. fully connected layer is a traditional multilayer perceptron structure. Its input is a one-dimensional vector representing the output of the previous layers. Its output is a list of probabilities for different possible labels attached to the image, like dog, cat, or bird, and the label that receives the highest probability is the classification decision. And the last note is on the pros and cons of the CNN architecture. And the pro is that the architecture allows CNNs to learn the position and scale of features in a variety of images, making them especially good at the classification of hierarchical or spatial data, and the extraction of unlabeled features. While the con is that, unfortunately, this structure requires CNN to only accept fixed-size inputs, and it only allows them to provide fixed-size outputs. So that's all for my presentation today. Is there any questions?
I think that was really good.
Okay, so I will stop sharing my screen.
I have a question.
Okay.
Yeah. So, how do you justify using like pooling and convolution? It's like loss of the information. How can you justify that?
You mean justify pooling and convolution?
Yeah, I mean by averaging several numbers into one, you're like losing the information to a certain degree. So what's the how do you justify that?
I think the whole point of the convolution is to reduce the feature space. So we're not losing information as much as we're like focusing the information that we're using for our network. If that makes sense.
Yes, and also we want to decrease the computational power required to process the data.
Okay, maybe.
So I don't know if I pronounce your name correctly, Zijing, right?
Yeah.
Yeah. So what Zijing is asking is exactly what I was proposing to add to the map. So let me give you a little bit of explanation on this, and whoever is interested, they can just find references about this and add more explanations to the map about this question. So the idea is sometimes, as you will explain, she will explain that part, that when you have structured data, like what? Like you are analyzing what are like you're analyzing or you're predicting a student's grades at the end of the semester, or you're predicting the stock market prices, you're forecasting the weather, or you're classifying like some species based on some characteristics. In all of these examples, we have structured data. For example, we have, in terms of students, we have their prior grades, their prior GPA, their gender, demographics, everything. In terms of like stock market prediction, we have the gold price, oil price. We have a lot of other like indexes that we include. And so for each of these problems, we have structured data available. Like we have a data set of columns, like features, meaningful features, and values for those features. And so we even don't need, in these examples, we even don't need to do anything for feature extraction. We just have meaningful features. We just need to train our model on those meaningful features. What if we're dealing with a problem without structured data, without meaningful features? For example, we have 2 million pictures of cats and dogs. And the question is, how can we train a model that can classify cats and dogs. For such a problem, as a human, when you look at each of these pictures, you see the very first thing you do is you identify whether at some part of this picture there is an animal. It can be cat or dog, it doesn't matter. But you identify where it is located. That is a very important point. For the deep learning model, how can you do that? How can you identify which pixels to choose to give to the deep learning model to train it? Identifying those pixels from the picture is a big task on its own. Now, if we, and on the other hand, there are a lot of noises. Like in the best case scenario, the picture includes only a cat or a dog, and the background is completely white. Nothing else, no noise. That is perfect. So it is easier for the model to understand. So this is the shape of the animal, cat or dog. Everything else is just white noise. But in most pictures, we have background picture. We have other stuff going around. We have trees, we have tables, chairs, a lot of different things. It's not just the picture of the animal. So in such a case, how can we extract features from the picture that can help identifying the type of the pet, cat or dog? The process of feature extraction on unstructured data is so complicated that it works and it is very beneficial to reduce the resolution of features to have less points available, less features, less pixels available than more. And we want to reduce the number of pixels to those that can give us more information. So this convolution, the reason I asked you to, I asked everybody to find images of how the convolution works is exactly because of this reason. I remember in this Coursera specialization or another textbook that I can find later, there were a lot of good examples of what happens when you put an image into these convolutional layers and you get the result. The result is amazing. So if you try multiple images, a large number of images, and you look at the convolution images, the results, you see, hey, patterns are showing up. And those patterns are the features that you're looking for. And when you look at the original pictures, it's a little bit more difficult to identify those patterns. Does this answer your question?
Yeah, partly. I fully understand why you're using the convolutional action.
I think I just sort of found an image for it. If I can share.
Yeah,
that.
I should check on the convolution concept later. Yeah, thank you.
Yeah, sure. Yeah, I'm just adding a link in the chat. You can look at it. I thought it made a lot of sense for why we're simplifying the image, doing the convolution thing. Yeah, sorry.
This is a really good image. Thank you.
Sure.
Oh, yeah. Thank you. So, if there's no more presentations today, maybe we can move on to discuss about the, I have made a draft of the requirements for starting reviewing research papers for our deep learning team. I have uploaded into our Microsoft Team channel. This is not applied to Jiayun, Jing, and Meta, and so it is for our deep learning team members. Nikki supervisee Zijing, and maybe the other new team members will join us in the future. So now we will have a discussion about it. And maybe I can share my screen. So in order to encourage everyone to propose new notes and give presentations, and to ensure that anyone who wants to start reviewing research papers is well prepared, here are the requirements for whoever would like to proceed to the next step, that is to reviewing the research papers. And for those who have free access to the courses, the requirements are finish all the courses with certificates earned and have presented at least 4 times on weekly meetings. The total number of notes covered in presentations is no less than 30. And for those who don't have free access to the Coursera and audit the courses instead, the requirements are have presented at least 6 times on weekly meetings, and the total number of notes covered in presentations is no less than 45. So that is a draft I just worked out, and for the numbers here, the 4, 36, and 45, do you have questions or suggestions about that?
Yeah, I have a question about, so I don't mind about, you know, having like a minimum number of nodes that people have proposed and put up, but I'm a bit concerned about having presented 4 times, because I feel like that just pushes everyone off by like 4 weeks before they can start reviewing papers. And I don't know if that's like a timeline we want to necessarily have in place, or if it makes more sense to just have people propose nodes and, you know, understand the material, finish all the courses, because I think that's what we should be focusing on.
Yes.
Just because, yeah, sorry, just because I feel like presenting at least 4 times on weekly meetings gives everyone. So we've already finished 2 weeks, which would mean everyone would have to wait at least 4 weeks before they can start looking at papers. And I think that's like a long time, and we probably shouldn't have that as a hard and fast rule, but that's just my opinion.
Yes, I want to explain that the reason I said this is that since everyone, since we have just got the new members into our deep learning team, and we have just started with the Coursera specialization as well as the book, I don't think they can finish it within a month for all the 5 courses and the whole book.
Meta, I feel like I agree with you on this. I feel like just directly going through research papers without having enough background, like building the foundations, is extremely important. If I just start going through the papers and I superficially understand what's going on in the papers, that doesn't help with the research.
I completely agree with that, Iman. I have no problem with like the first point, which I think is paramount, which is about finishing all the courses in the textbook. I don't know if it's I wasn't sure if we wanted to put like that 4-week whole period, but I think, you know, it makes sense if everyone's okay with it.
So basically, why we should present 4 times is that you want to make sure we are on the same page.
Right.
What kind of page? What kind of things have you already learned? I want to know whether I already have a good amount of them.
Nothing. We just started. So Yua has recorded last week's presentation, and she's going to share with us on our YouTube channel. So you can just go through what she presented last time. and you attended this meeting. So this is the only thing we have covered so far. Nothing complicated.
Got it.
And one more thing. So you mentioned there may be a couple of people who don't have free access to the Coursera specializations or courses. I feel like everybody has free access to the courses. The difference is there are some people whose schools provides them with a free access to get the certificate after like completing the courses. Some schools don't have that contract with Coursera, and you can just audit if your school doesn't have a contract with Coursera. That's totally fine. You still can audit the courses, and you can have free access to all the content. The only difference is that at the end of the day, you don't get the certificate, which is I don't see a lot of benefit in getting that certificate as long as you're working on a research project and you publish papers.
Yes, and I also want to explain why those who don't have certificates have to give more times of presentations and more notes. This is because that those who got the certificates have to pass the quizzes of the course and finish the programming assignments in the specialization. However, those who audit the course may not have access to these sources or don't have to finish this stuff, so maybe they have to give more presentations. Yeah.
And in our teams, so this is one of our research teams, like deep learning is one of our research teams. And in most of our teams, the decisions we make are based on majority of votes. I even do the same thing in my courses. So later on, if you have ideas to change this requirement, please just explain your ideas. We'll vote on them and we can change them. So nothing is rigid, and everything is flexible. But for now, we feel like this is a good requirement. So if you have any concerns, any ideas, just let us know about them.
Do we have to do the presentation on the platform that I just showed before? Because I don't think the format is very good to keep a track of.
So
use Microsoft PPT is better way, in my opinion.
So here's the problem. So find a platform where we can all collaboratively write and read from. We have specifically developed this platform to be able to write and read together, to propose improvements, to vote on what others have proposed, and so on. If you have any better ideas, like any better platforms in mind that we can use to collaboratively read and write and use for our collaborative research, please just share it with us.
Okay, I understand.
And by the way, we are still working on the design of this platform. It's not perfect yet, but this is another multiple research teams are working on this platform. So, and we have been using this in COVID-19 research, in our UX research, kind of psychology research, and other stuff. And the good thing is that you can find all the summaries, all the literature reviews, all the ideas that other people from our other research teams have contributed to this same platform. Like you can find a lot of stuff about causal inference and machine learning. You can find a lot about UX research in online communities. You can find about learning science and kind of psychology of like memory science and those things. that, and all of this is shared in the same page, in the same platform. So we can just, when you search, you can find a lot of stuff that may be related to what we're doing, what we're researching, and we can find creative ideas by connecting these things. Do you see the reason we're using this?
Yeah, got it. I understand. It's to keep the record.
Right. So these benefits are not for free. These benefits have like costs associated with them, and the cost is this platform is still under development. There are still bugs. They're not, like, the design is not perfect for the purpose of presentation and other things. But so as far as I know, I don't know any other platform like this that we can share all our research together and collaborate on improving what we have already learned and what we learn every day. Like, whatever I learned from different papers, from different books, whatever, I just share with the rest of the teams who are collaborating with me on this platform. And they also, other people from other teams also share on this platform. So I can learn from them, they can learn from me, and we can continue this way.
Yeah, I agree with that. I think One Academy, at least at the moment, is the best choice for us, since we can collaborate together and share together. And the node and link, the map structure can be very helpful for us to understand the relationship between multiple concepts and have over the whole view of how the deep learning is like. Yeah. So any more questions for the requirements here? Okay, so I will just have it as our requirements for proceed to the next step. And I would also like, I have also upload an Excel in our channel. And this can keep the records for the presentations you have made. Yeah, Jean has already put her name on it. So you can, each time you would like to give a presentation in the weekly meeting, you can just put your name and the number of notes here so that we can keep the records. And whoever has meets the requirements can then send a private message to me to move on to the next step. Okay, so I think maybe we don't have other things to be covered in today's meeting. If there is no more questions, maybe we can end today's meeting.
Thank you.
Thank you.
Thanks. Bye.
Bye.